Hey guys, this is Malinki. Welcome back to my channel, Voice of Malinki. Today we will talk about modes of life in Polychaetes. And if you are new in my channel, please subscribe my channel. And if you like my video, please do like, comment and share my video. So Polychaetes is the largest class of phylum Annelida. It shows greatest diversity in this phylum. And here is the discussion of the adaptive diversity of Polychaetes. So, adaptive diversity according to habitat. First one is crawling Polychaetes. They are marine. They move freely on the seafloor. They have well-developed sense organs such as eyes, tentacles, antenna, CD, and pulse. Locomotion. Parapodia and CT are there to crawl and move on the seafloor, often among rocks and stones. Feeding. They are carnivorous animals. They use their irreversible pharynx, that is the feeding organ, with chitinous jaws and denticles to capture prey. So what is irreversible? So irreversible means being turned inside out. Turned inside out. So this type of pharynx they have, that is their feeding organ, and they also have chitinous jaws. Jaws are made up of chitin and teeth to capture the prey. Example, nereid. Next is pelagic Polychaetes. They are also known as planktonic Polychaetes. They are also marine. They live in the open ocean rather than crawling on the seafloor. They are semi-transparent. That helps them evade predators. So predators cannot find them easily since they are semi-transparent. Some of them have large eyes while some of them lack eyes completely. Parapodia are small. They move using lateral undulation. Undulation is a type of movement where they move up and down. Move up and down. Feeding, they are predators. Cilia are longer and carry tangoreceptors which help in locating the food. Example, vanadis. Next is burrowing Polychaetes. So they are also marine worms. They live in burrows within sand. They use various methods to move through and maintain these burrows, including muscular contractions, parapodia, and CT. So they use these stuff to maintain the burrows. Burrowing provides them with shelter, access to food and oxygen, and protection from predators and environmental stressors. So burrowing helps them to protect themselves, and they get food, they get oxygen, and they get protection from the predators. Body has become smooth and parapodia have become small to give minimum friction during burrowing. So they have very smooth body and they have small parapodia which help them to stay like with the minimum friction during their burrowing. And their city have become hook-like to anchor in the burrow. Example, Arenicola. Next is tuberculous Polychaetes. Tube-dwelling Polychaetes there. They are also marine worms. They live permanently inside tubes, often constructed of mud, sand, or other materials such as mucus, shells, parchment, or calcium carbonate, depending on the species. Okay. They are sessile. They do not move. They remain anchored in their tubes, and they rely on tentacles to capture food from the surrounding water. So they have tentacles which help them to capture food. Example, platinary. So these are, we have talked about like their adaptive diversity according to habitat. Now we will see the adaptive diversity according to the nutrition. So first one is raptorial feeders. They are actually carnivorous like Nereis. Detritus feeders, from the name itself, you can understand that they are dependent on dead materials. So sea bottom is source of dead organic matter which is consumed by sedentary Polychaetes species. So they are sedentary species, they do not move and they get the dead organic materials and get nutrition from them. So they are detritus. An example is cerebella. Next is filter feeders. So most of the sedentary and tuberculous polychaetes are filter feeders. So who cannot move easily, they are generally filter feeders. So filter feeders feed by filtering out nutrients suspended in the water. Filtering out nutrients suspended in water. So this is all about today's lecture. I hope you liked the lecture. Thank you for watching my video.